Alright guys, today we are going to be looking at lesson 7.1, relations and functions. Okay, so our learning target today is to understand the concept of a function. Success criteria: I can represent a relation as a set of ordered pairs. I can determine whether a relation is a function, and I can use functions to solve real-life problems. Okay, so ordered pairs can be used to show inputs and outputs. Okay, so inputs, okay, is the same thing as the x values, okay, in a relation or mapping diagram, okay, and the outputs is the same thing as the y value. Okay, we also might see the x value or the inputs referred to as the domain, and the y value or the outputs referred to as the range. Okay, so you can see here we have a set of ordered pairs. So in blue are all the inputs or the x values, and in red are all the outputs or the y values. Okay, so when we are looking at a relation, okay, we can represent a relation using ordered pairs or a mapping diagram. Okay, so the difference between an ordered pair and a mapping diagram is the mapping diagram lists the inputs in one box, the outputs in a second one, okay, and the inputs and outputs are connected with arrows. Okay, if there was an input or output that was repeated, we wouldn't write it twice, we would just draw a second arrow. So let's look at some examples here. Okay, so we are starting with a mapping diagram, and they ask us to list the ordered pairs shown. So if I were listing the ordered pairs for this, this first one, 1 is paired with 3, 2 is paired with 6, 3 is paired with 9, and 4 is paired with 12. Okay, for the second one, make sure you're following these arrows. Okay, 0 is paired with 0. 2 is paired with 1. And then you'll see 2 is also paired with -2. And then 4 is paired with -3. Okay, so those would be your ordered pairs from the mapping diagram. Okay, a relation that pairs each input with exactly one output is a function. Okay, so let me read that one more time. A relation that pairs each input with exactly one output is a function. So I'm going to go back to those examples we just looked at. Okay, so in example A, each input matches to one output. Okay, so in example A, this would be a function. Okay, in example B, you can see that the 2 is paired with both 1 and -2. Okay, so this input has 2 different outputs. So that means B is not a function. All right, so let's try looking at the examples below. Okay, so same thing, right? If I am looking at each input paired with the outputs, well here, -9 is paired with 0, -2 is paired with 5, 5 is paired with 10, and 12 is also paired with 10. Okay, this is okay. Okay, it's okay that the output is repeated, okay, because each input has its own output. Okay, I know that the answer to 5 is 10, and the answer to 12 is also 10, okay, but they each have a single answer. So in A, this would be a function. Okay, in B, however, when we look at those ordered pairs, we can see that -2 is paired with 4, -1 is paired with 3, and then here's where the problem occurs. right? 0 goes to 5, and 0 goes to 6, okay? So because 0 has two different outputs, okay, this one is not a function. I'm going to finish writing my ordered pairs, though. 1 was with 6, and 2 was with 7, and this one we said is not a function. Okay, so it is okay if the y value is repeated, okay, as long as it has its own unique x value. But if an x value, okay, is repeated or pairs with more than one output, okay, then it is not a function. Okay, so this is a function. I'm going to write the reasoning because each input has exactly one output. Okay, and this one is not a function because 0 has two outputs, right? Both 5 and 6. Okay? All right, last example here. And you'll notice that I added a third question here as a little extension. All right, so this one says the mapping diagram represents the prices of one-way subway tickets to different zones of a city. Is the price of a subway ticket a function of the zone number? Okay, so if we look at this, right, each input has one output. So yes, this would be a function. All right, B says describe the relationship between the price and the zone number. So if I were looking at this relationship, I can see that this is a linear relationship, right? Where my slope, okay, is going up by $1.50, right? Each time we jump a zone, right? And the zones are just going up by 1. Okay, so my slope here is going to be 1.5x, right? And my y-intercept, okay, or zone 0, right, was $2. So that's going to be plus 2. All right, so in C, okay, I told us now we want to try to write this equation in function notation. So function notation, okay, is just instead of writing y, you are going to write a letter, and this letter can change, okay, but generally we use f of x. Okay, you'll notice I didn't change anything to the right side of the equation. All I did on the left was, again, I replaced y with this term, which we read f of x. Okay, f of x. So again, all that means is it's the y value. Okay, so if I was looking at the second part of that question, it says find the price if they added a zone. Okay, so what they're asking, right, if we added zone 4, right, around our little picture here, right, if we had zone 4, okay, what would the price of zone 4 be? Okay, so in order to solve that, I'm going to call that letter D, right? In order to solve that, okay, if I want to find zone 4, okay, what they're saying is the x value is 4, okay? So I am going to write that as f of 4. Okay, so all this is saying, right, is that the x value is 4. Okay, so this is just a fancy way to write out a substitution problem. So I'm going to do 1.5 times 4 plus 2. So f of 4 would equal 6 plus 2, which is 8. Okay, which is just telling me that this ordered pair is 4, 8. Or this value in the mapping diagram, right, is 4, 8. Okay, so we are going to explore function notation a little bit further. Okay, but I wanted you guys to see that function notation and be able to read it. Okay, it doesn't matter what letters there. I did f of x, but it could be g of x or h of x. Okay, any variable could be in that spot. Okay, and then whatever is in parentheses, again, that is just telling you what the x value is that you need to substitute into the equation that you have. All right, guys, that is it for the notes today. So make sure that you have these notes written down in your guided notes packet, and then you can return back to the agenda to see what is next.